Welcome to the quiet space of our community where sleep stories live. Maybe it's been a long day, or maybe you just love drifting off with thoughts of distant cosmos instead of counting elephants. Today we'll gently immerse ourselves in the world of the most amazing astronomical facts, those that shine with quiet calm and remind us how boundless, mysterious, and tender the universe can be. We'll touch upon stars, nebulae, distant worlds, and cosmic rhythms that can soothe better than any lullaby. You don't need to do anything right now. Just settle in comfortably. Allow your breathing to slow down, your thoughts to soften, and your body to become light, as if gravity has loosened its grip. We'll go slowly, gently, just one sleepy fact at a time, leaving everything else beyond the boundaries of this night. And before we begin, if these quiet journeys help you relax and gently end your day, touch the like button and subscribe to the channel. It helps others find their way here too, as if one by one we're lighting nighttime beacons of calm. And now, settle in comfortably and let's begin. Stars are born in clouds of dust. Every star begins as a quiet cloud of gas and dust somewhere far away in space. This cloud slowly compresses under its own weight. For years, for millions of years, when the center becomes hot enough, a fire ignites, a thermonuclear reaction, and a new star is born. It's like the slow breath of the universe. Inhale, the cloud compresses. Exhale, the star flares up. Our sun was born exactly this way 5 billion years ago. And right now, at this very moment, somewhere far away new stars are being born. The sun can hold 1 million Earths. Our sun is so large that almost 1 million planets the size of Earth could fit inside it. Imagine 1 million worlds, 1 million oceans, 1 million skies. All of this could fit inside one star. And this isn't even the largest star in the universe. Astronomers say the sun is an ordinary average star. There are stars hundreds of times larger. But for us, the sun is exactly what we need. Not too large, not too hot, just right to keep us warm and safe. It shines steadily, calmly, billions of years in a row. There are more stars in the universe than grains of sand on Earth. If you gathered all the grains of sand from all the beaches and deserts of the planet, there would still be fewer of them than stars in the visible universe. This is hard to imagine. Each of those stars is a sun, possibly with its own planets, its own worlds. We see only a tiny fraction of them, those that are close enough and bright. But they're there, billions and billions, quietly shining in the darkness, even if no one is looking at them. And this is comforting. You're not alone in this vastness. You're part of something boundless. Stars are born in clouds of dust. Every star begins as a cloud of gas and dust somewhere far away in space. This cloud slowly compresses under its own weight over millions of years. When the temperature at the center reaches a critical point, a thermonuclear reaction launches, and a new star is born. Our sun was born exactly this way 5 billion years ago. It's like the slow breath of the universe. Inhale, the cloud compresses. Exhale, the star flares up. And now let's look at the size of the sun itself. The sun can hold 1 million Earths. Almost 1 million planets the size of Earth could fit inside the sundae. This means the volume of our star is 1 million times greater than the volume of the planet you're lying on right now. At the same time, the sun is an ordinary, average star by cosmic standards. There are stars hundreds of times larger than it. Imagine 1 million worlds that could fit in one point in the sky. Now, about the number of such stars in space. There are more stars in the universe than grains of sand on Earth. All the grains of sand from all the beaches and deserts of the planet, there are fewer of them than stars in the visible universe. Astronomers estimate the number of stars within the observable cosmos at hundreds of sextillions. That's a number with 23 zeros. Each of those stars is a sun, possibly with its own planets. We see only a tiny fraction, those that are close enough and bright. And the nearest one is very, very far away. The nearest star is 4 light-years away. Proxima Centauri is located 4.5 light-years away from us. Light travels at 300,000 kilometers per second. Even at that speed, it takes 4 years to get from Proxima to Earth. If you flew on the fastest rocket, the journey would take tens of thousands of years. It's like living on a small island in the middle of a huge ocean of darkness. But there's something closer. Our satellite. The moon is slowly moving away from Earth. Every year, the moon moves away from us by approximately 4 centimeters. This happens due to tidal friction, the interaction of the moon's gravity and Earth's oceans. In the distant past, the moon was much closer and appeared much larger in the sky. In billions of years, it will move so far away that total solar eclipses will become impossible. But this happens so slowly that nothing will change during your lifetime. The moon will continue to shine just as calmly. A day on Venus is longer than a year. It takes Venus 243 Earth days to rotate around its axis. At the same time, the orbit around the Sun takes only 225 days. This means one day there is longer than 1 year. In addition, Venus rotates in the opposite direction from most planets. The Sun rises in the west there. Imagine a world where dawn comes once a year, and on another planet the day is endless altogether. One side of the moon is always hidden. The moon is always turned toward Earth with one side. This happens due to tidal locking. The moon rotates around its axis in the same time as around Earth. Therefore, we never see the reverse side from the planet's surface. People first saw the dark side of the moon only in 1959, when a Soviet station orbited the satellite. There's nothing mysterious there, just rocks and craters, like on the visible side. But another planet hides something much more interesting beneath the surface. Under the ice of Europa lies an ocean of water. Jupiter's moon, Europa, is covered with a thick layer of ice, beneath which a liquid ocean splashes. This ocean contains more water than all the oceans of Earth combined. It exists thanks to gravitational friction. Jupiter squeezes and stretches Europa, heating it from within. There, in the darkness beneath kilometers of ice, life may possibly exist. This is one of the most promising worlds for the search for extraterrestrial organisms. And nearby is the most volcanic body in the solar system. Io is the most volcanic world. Jupiter's moon Io constantly erupts lava from hundreds of volcanoes. Jupiter's gravity squeezes and stretches this satellite so strongly that its interior remains molten. Io's surface is renewed every few thousand years. This is the youngest surface in the solar system. Lava ejections rise hundreds of kilometers in height. This is a hellish world of frozen sulfur and eternal volcanoes. But the calmest planet is completely different. Saturn could float in water. Saturn's density is less than the density of water. If a sufficiently large ocean were found, Saturn would float on the surface like a giant ball. This happens because the planet consists mainly of light gases, hydrogen, and helium. At the same time, Saturn is the second largest planet in the solar system. Imagine a world the size of 100 Earths that weighs less than water, and its rings are even stranger. Saturn's rings are thin as a sheet of paper. With a width of over 270,000 kilometers, Saturn's rings have a thickness of only about 10 meters. If you reduce them to the size of a football field, they would be thinner than paper. The rings consist of billions of icy particles, from dust specks to huge boulders. They constantly collide, break apart, and stick together again. This is the most fragile and most beautiful structure on a planetary scale. Now let's look at the coldest planet. Uranus lies on its side. Uranus's axis of rotation is tilted at 98 degrees. This means the planet essentially rolls along its orbit, lying on its side. One pole faces the sun for 42 years, then comes a 42-year night, and the sun shines on the other pole. Scientists still don't know for certain what caused such a tilt, probably an ancient collision with a large object. This is the strangest rotation in the solar system, and the fastest winds blow on the last planet. Winds on Neptune are faster than sound. Winds on Neptune reach speeds of over 2,000 kilometers per hour. These are the fastest air currents in the solar system, faster than the speed of sound on Earth. At the same time, Neptune is the most distant large planet from the Sun, and it's extremely cold there. Scientists still don't understand where the energy for such storms comes from. Imagine a world where wind can outrun sound. Now, let's return to our galaxy. The Milky Way has 4 arms. Our galaxy is a spiral structure with 4 main arms. We live in a small arm of Orion, between 2 large arms, Perseus and Sagittarius. The solar system is located approximately 26,000 light-years from the center of the galaxy. This is a quiet, relatively safe area, far from the chaos of the central regions. We live on the outskirts of a large galactic city, and at the center of this city is something huge. At the center of the galaxy is a black hole. The supermassive black hole Sagittarius A star is located at the very center of the Milky Way. Its mass equals approximately 4 million solar masses. Astronomers know about its existence thanks to the movement of stars around the center. They orbit at tremendous speed around an invisible object. In 2022, scientists first obtained an image of this black hole. It swallows everything that approaches too close, even light. But right now, it's sleeping, almost not absorbing matter. Galaxies will collide in 4 billion years. The Milky Way and the Andromeda Galaxy are approaching each other. In approximately 4 billion years, they will merge into one large galaxy. But this isn't a catastrophe. The stars won't collide because the distances between them are enormous. The galaxies will simply intertwine, giving birth to new stellar systems. Scientists have already come up with a name for the new galaxy, Milchromeda. This is a slow gravitational dance that will last millions of years. Earth will probably survive this merger without significant changes. Light from distant stars travels thousands of years. When you look at the night sky, you see the past. Light from a star located 1,000 light-years away traveled to your eyes for 1,000 years. Some stars you see now may no longer exist. They exploded, but their light is still on its way. The sky is a window into different moments of the past, scattered throughout the universe. Each star shows you what it was like once, not now. And some of these stars will soon disappear from the sky. Betelgeuse could explode any moment. The red supergiant Betelgeuse in the constellation Orion is approaching the end of its life. When it explodes as a supernova, the flash will be visible even during the day for several weeks. It will shine like a full moon in the night sky. Scientists don't know exactly when this will happen. Maybe tomorrow, maybe in 100,000 years. On cosmic scales, any moment means a very wide time span. But when it happens, we'll see the brightest show in human history. And distant stars leave beautiful traces behind them. Nebulae are the remains of dead stars. When a star dies, it ejects its outer shells into space. These shells scatter, creating huge clouds of gas and dust. Nebulae. They glow in different colors depending on the composition of the gas. From these nebulae, new stars are eventually born. This is an endless cycle. Stars are born, live, die, and from their remains new ones grow. The death of one star gives life to others. Everything in the universe is recycled and returns again. You consist of stardust. Every atom in your body was once part of a star. The hydrogen in water, the calcium in bones, the iron in blood. All of this was created in the cores of stars billions of years ago. When stars exploded, they scattered these elements across space. From this dust, Earth formed, and then you. You're literally made of matter that was born in the hearts of distant suns. This makes you part of the cosmos, not just an observer. Time slows down near massive objects. Near black holes and neutron stars, time moves slower than on Earth. This is called gravitational time dilation, a consequence of Einstein's theory of relativity. If you could stand near the event horizon of a black hole for a minute and return, years would have passed on Earth. For you, 60 seconds would have passed, and for everyone else, much more. Time isn't a constant, but something flexible that depends on gravity. In space, time flows differently in different places. In space, there is absolute silence. Sound cannot propagate in a vacuum. Sound waves need a medium, air, water, solid matter. In space, there's no air, so there's absolute silence. Even if a supernova exploded nearby, you wouldn't hear anything, only see the flash. All sounds of spaceships in movies are fiction for atmosphere. Space is the quietest place that exists. There reigns eternal, absolute silence. One day is 24 hours only on Earth. On Mars, a day lasts 24 hours 39 minutes. On Jupiter, less than 10 hours, because the planet rotates very quickly despite its size. On Venus, as we already know, a day lasts months. Each world has its own rhythm, its own duration of a day. What we call a day is only an earthly measure. There is no universal clock in the universe. Each planet lives in its own time. Cosmic space is not empty. Even in the deepest vacuum, there are particles. In every cubic meter of space, there are several hydrogen atoms, plus cosmic radiation, dark matter, dark energy. The space between stars is filled with thin gas, dust, magnetic fields. This isn't emptiness in its pure form. This is a very rarefied but still filled medium. Space is an ocean, not emptiness. It's just that this ocean is extremely rarefied. The temperature of space is -270 degrees. The background radiation of the universe has a temperature of about 3 kelvins. That's -270 degrees Celsius, the remnant heat from the Big Bang. This weak signal fills all of space evenly, in all directions. Scientists discovered it in 65 of the last century, and it became one of the greatest proofs of the Big Bang theory. The entire universe bathes in this ancient cold light. It reaches us from the very beginning of time. The universe is expanding ever faster. Galaxies are moving away from each other with acceleration. Scientists discovered this in the 90s and were shocked. They expected that expansion should slow down due to gravity. But something is pushing space to expand faster. This is called dark energy. No one knows what this is, but it makes up about 68% of all the energy in the universe. The space between galaxies is growing, and this speed is increasing. In billions of years, distant galaxies will disappear beyond the event horizon. Dark matter is invisible, but holds galaxies together. Approximately 27% of the universe is dark matter. We cannot see it, but we know about its existence thanks to gravity. Stars at the edges of galaxies move faster than they should according to the laws of physics. Invisible mass holds them. Dark matter permeates everything, passes through you every second, but doesn't interact with normal matter. Most of the universe consists of something we don't see and don't understand. This is one of the greatest mysteries of modern science. A neutron star weighs as much as the sun but is the size of a city. When a massive star explodes, its core compresses into a neutron star. The diameter of such a star is about 20 kilometers, but the mass exceeds the mass of the sunday. 1 teaspoon of neutron star matter would weigh 1 billion tons. Gravity there is so strong that time slows down and space curves. This is the densest matter in the universe after black holes. And some neutron stars also rotate at incredible speed. Pulsars rotate hundreds of times per second. Pulsars are neutron stars that rotate very quickly. Some make hundreds of rotations per second, emitting beams of radio waves. When the beam is directed at Earth, we receive a regular signal, like a cosmic lighthouse. Pulsars are so precise that they can be used as cosmic clocks. Imagine an object the size of a city spinning faster than fan blades. And there are objects even stranger, black holes. Black holes don't suck everything around them. A black hole has ordinary gravity, like any object. If the sun suddenly turned into a black hole of the same mass, Earth would continue to orbit along the same orbit. Black holes are dangerous only if you approach very close, beyond the event horizon. At a safe distance, they act like ordinary massive objects. They don't wander in space, sucking everything in a row. They're just very compressed mass with enormous gravity. Near a black hole, time almost stops. If you approach the event horizon, time for you would pass normally. But for an outside observer, you would move slower and slower. Near the horizon itself, it would seem that you froze in time. From your point of view, a moment would have passed, and in the universe, millions of years. This is the most extreme time dilation possible. Black holes aren't just objects in space, but ruptures in time. Near them, time flows differently. Quasars are the brightest objects in the universe. A quasar is a supermassive black hole actively absorbing matter. Matter falling into a black hole heats up to millions of degrees and shines brighter than trillions of stars. Some quasars are visible from a distance of billions of light years. They shine brighter than entire galaxies. Now there are almost no quasars left. They were common in the young universe. The brightest light is born on the edge of the deepest darkness, and some stars shine in a spectrum invisible to us. Most stars are invisible to the human eye. We see only bright stars in the visible spectrum, but red dwarfs exist, the most common type of stars, which barely shine. There are billions of them, but we don't see a single one with the naked eye. There are also brown dwarfs, not quite stars, not quite planets. They're too small to start thermonuclear reactions. The night sky you see is only the tip of the iceberg. Most of the universe is hidden from our eyes. Light can bend around massive objects. Gravity curves space, and light follows this curvature. When a beam of light passes by a massive star or galaxy, it bends. Sometimes this creates a gravitational lensing effect. We see several images of the same object. Astronomers use this to find distant galaxies that would otherwise be invisible. Massive objects act as natural telescopes in space. They allow us to see what is too far away. Some planets wander without stars. In space, there are rogue planets that don't orbit any star. They were ejected from their systems by gravitational interactions and now drift in the darkness between stars. Astronomers believe there may be billions of such planets, perhaps even more than stars. They're cold, dark, lonely worlds that never see dawn. Imagine a planet wandering in absolute darkness for billions of years, without a sun, without warmth, without hope for light. There are planets with diamond rain. On Neptune and Uranus, it may rain diamonds in the atmosphere. Enormous pressure and temperature turn methane into carbon, which crystallizes into diamonds. These diamonds fall down through the thickness of the atmosphere, possibly forming entire oceans of liquid carbon at depth. This is one of the strangest weather phenomena in the solar system. Where we see clouds, there may be treasure. And some worlds are even stranger. It rains molten glass there. On some exoplanets, there are winds of glass. Planet HD 189733b has a blue color like Earth, but for a different reason. There, winds whistle at speeds of 7,000 kilometers per hour, and the atmosphere contains silicate particles, molten glass. This means the planet literally has sideways rain of glass at a temperature of about 1,000 degrees. Imagine a world where the sky is blue, but every raindrop is molten glass. Space is full of things beautiful and deadly at the same time. There's a planet where a year lasts 8 hours. Exoplanet K2137b orbits its star in 4 hours. It's located so close to the star that the surface temperature exceeds 2,000 degrees. One side of the planet is always turned toward the star and molten. The other is in eternal darkness. A year there is shorter than an Earth workday. There are no changing seasons, no cycles. only eternal heat on one side and darkness on the other. And some planets have several suns in the sky. Some planets orbit two stars. Planets in binary star systems see two suns in the sky. Like Tatooine from Star Wars, this isn't fiction. Such planets really exist. Astronomers have found dozens of such worlds. Their sunsets look different. First one star sets, then the second. Sometimes both stars set simultaneously, creating a double shadow. Imagine a world where the sky has two centers, two sources of light, where shadows are always double. Interstellar space is filled with radiation. Cosmic rays are high-energy particles flying through the galaxy. They're born in supernova explosions and accelerated by magnetic fields to enormous speeds. Every second, billions of such particles pass through your body, but Earth's atmosphere and magnetic field protect us from most of them. Without this protection, life on the planet's surface would be impossible. We live under an invisible shield. Earth moves through space at over 1 million kilometers per hour. Earth orbits the Sun at a speed of 107,000 kilometers per hour. The solar system orbits the center of the galaxy at a speed of 220 kilometers per second. And the galaxy itself moves through the local cluster of galaxies at an even greater speed. Adding up all these movements, you're racing through space faster than any rocket. But you don't feel this movement because everything around moves with you. This is the calmest race in the universe. Several new stars are born every second. In the visible universe, about 3 new stars are born per second. Some galaxies are star factories where hundreds of new luminaries appear per year. Others, like our Milky Way, are more calm, about 3 new stars per year. But in the entire universe, the process never stops. While you're reading this, a new star is being born somewhere, and somewhere else, another one is quietly fading. Stars live billions of years. The lifespan of a star depends on its mass. Red dwarfs, the smallest stars, can shine for trillions of years. Our sun will live about 10 billion years. It's now in the middle of its life. Massive stars burn out quickly, in a few million years, and explode as bright supernovae. The larger the star, the shorter it lives. This is cosmic irony. The brightest stars fade the fastest. The sun loses millions of tons of mass every second. The sun converts 4 million tons of matter into energy every second. This energy flies out in the form of light and heat. But don't worry, the sun has enough mass for another 5 billion years of calm shining. The loss is so small compared to the total mass that the star doesn't even notice it. The sun is gradually becoming lighter, but this process is so slow that it doesn't affect us. It will continue to shine stably for a very, very long time. Space smells like burnt metal and grilled steak. Astronauts returning from open space notice a strange smell on their spacesuits. They describe it as a mixture of burnt metal, welding, and fried meat. This is the smell of remnants of high-energy particles that settled on the suit material. In space itself, there's no smell. It's a vacuum. But substances returning from space carry this unusual aroma. Space has a smell, though it itself is empty. And some places there smell like rum and raspberries. At the center of the galaxy is a cloud that smells like raspberries. Astronomers discovered ethyl formate in the gas dust cloud Sagittarius B2. This is a substance that gives raspberries their aroma. The same cloud contains ethyl alcohol, the same as in alcohol. There's enough alcohol there to fill billions of bottles. But you shouldn't fly there for a cocktail. The cloud is located 26,000 light-years away. Inside our galaxy floats a huge cloud that smells like fruit and rum. The universe is stranger than any fiction. The moon is moving away, and someday solar eclipses will disappear. In a few 100 million years, the moon will move so far away that it won't be able to completely cover the Sunday. Right now, we live in a unique period of Earth's history when the visible sizes of the moon and sun in the sky are almost identical. This allows us to observe total solar eclipses, one of the most beautiful astronomical phenomena. In millions of years, our descendants won't see this. We live in a special time when the sky puts on this show. This is temporary beauty. Satellites exist not only for planets. Even some asteroids have their own small satellites. Asteroid Ida has a satellite dactyl about 1.5 kilometers in size. Dozens of other asteroids also have companions. Some asteroids are even binary, two objects of approximately the same size orbiting a common center of mass. Gravity works at all scales. Even the smallest objects can have their own moons. Comets have two different colored tails. When a comet approaches the sun, it develops two tails. One consists of ionized gas and glows blue. The solar wind pushes it directly away from the Sunday. The second is made of dust. It's white and goes in a slightly different direction, following the comet's orbit. Both tails are always directed away from the sun, regardless of the direction of movement. A comet never flies tail first. The solar wind always pushes the tails back. Some meteorites are older than the solar system. In meteorites, dust grains have been found that formed before the birth of the Sunday. These pre-solar grains arrived from other star systems and survived during the formation of our system. They're more than 5 billion years old. This is literally dust from times when our star didn't yet exist. In your hands may be a stone older than the Sunday, a fragment of history that survived the birth of worlds. Aurora exists on other planets too. Jupiter and Saturn have the most powerful auroras in the solar system. Aurora on Jupiter is thousands of times brighter than Earth's. It glows not only from solar wind, but also from volcanic emissions of the moon, Io. Even Mars has local flashes of aurora over ancient magnetic anomalies in the crust. Every planet with a magnetic field has its own dance of light. Aurora is a universal phenomenon in the universe. The James Webb Space Telescope looks into the past. Launched in 2021, the Webb Telescope observes the most ancient galaxies. It sees light that has traveled to us for 13 billion years, almost from the very beginning of the universe. These galaxies existed when the universe was young. Some of them have long since disappeared, but their light is only now reaching us. This telescope is a time machine. It shows us the childhood of the cosmos. The universe is approximately 13.5 billion years old. Scientists determined the age of the universe thanks to background radiation. The Big Bang happened 13.8 billion years ago. Since that moment, space has been expanding, galaxies moving apart, stars being born and dying. We live in a universe that's still young. Ahead are still trillions of years of star existence. The history of the cosmos is only beginning. We live at an early stage of an infinitely long history. The first stars were giant. After the Big Bang, only hydrogen and helium existed. The first generation of stars formed from this pure material. They were enormous, hundreds of times more massive than the Sun, and lived only a few million years. When they exploded, they created all the heavier elements: carbon, oxygen, iron. Thanks to them, the existence of planets and life became possible. We consist of the ashes of those first giant stars. They lived fast, died brightly, and left us a universe rich in elements. Gravitational waves are ripples in space-time. In 2015, gravitational waves were registered for the first time. They arise when massive objects, black holes or neutron stars, merge. These waves stretch and compress space itself, passing through the universe. The detection of gravitational waves confirmed Einstein's last great prediction. Space isn't an empty stage, but a living fabric that can vibrate. We've learned to listen to the sounds of the cosmos. Some stars pulsate like hearts. Cepheids are stars that regularly increase and decrease in brightness. They pulsate with a precise period, from days to months. Brightness and period are connected, so astronomers use cepheids as standard candles for measuring distances in space. Thanks to them, we learned how large the universe is. Some stars breathe with light, and this rhythm helps us understand the scale of the cosmos. There are stars colder than the human body. Brown dwarfs are objects between stars and planets. They're too small to start true thermonuclear reactions. Some of them have temperatures below 100 degrees Celsius, colder than hot coffee. These are the coldest stars in the universe, although actually they're not even quite stars. In space, there are objects you can touch with your hand without getting burned, but they're still millions of times more massive than Earth. Magnetic storms can shut down electricity. In 1859, a geomagnetic storm knocked out telegraph lines worldwide. This event, known as the Carrington event, remains the most powerful recorded magnetic storm. Aurora was seen as far as Cuba and Hawaii. If such a storm happened today, it could disable satellites, power grids, GPS. But this isn't a catastrophe, just a reminder that we live in a system where the Sun and Earth constantly interact. Space isn't distant and separate. It touches us every day through invisible connections. You're looking at the same moon as ancient people. The moon has hardly changed in thousands of years of human history. The same craters you see were seen by Egyptians, Greeks, dinosaurs, millions of years ago. The moon is the most stable object in our sky. It connects us with everyone who ever looked up and wondered about the cosmos. This is the same satellite that shone over the first humans, and it will shine over the last ones. The space between stars is enormous. The nearest star is so far away that even light needs 4 years to reach it. If you reduce the Sun to the size of a pea, Earth would be a grain of sand a meter away from it, and the nearest star would be another pea 300 kilometers away. Space isn't just large, it's mostly empty. Stars are rare islands of light in an ocean of darkness. The loneliness of stars in space is almost absolute. But even in this loneliness, beauty is born. You've never seen the true color of stars. Most stars appear white, but they're actually colored. Cold stars are red, hot ones are blue, Medium ones, like the sun, are yellow. But our eyes in darkness work mainly in black and white mode, so stars appear to us as white dots. Only the brightest stars, like Betelgeuse or Rigel, show their true color. The night sky is actually colorful. Our eyes just don't see the full palette in darkness. Some constellations have existed for thousands of years. People have been seeing the same patterns of stars for millennia. Orion, Ursa Major, Cassiopeia. They look almost the same as in the times of the ancient Greeks. Stars move, but so slowly that changes are imperceptible during a human lifetime. In hundreds of thousands of years, these patterns will change, but right now the sky looks the same as in the times of the first civilizations. We're looking at the same sky as our ancestors. It connects us through time. In space, time goes differently. For an astronaut in orbit, time moves a little faster than on Earth. This is a consequence of the theory of relativity. Gravity slows down time. The difference is microscopic, a few milliseconds per year, but it's real and measured. GPS satellites account for this difference. Otherwise, navigation would work inaccurately. Time is not absolute. It flows differently depending on where you are. The universe may be infinite. No one knows where the universe ends, or if it ends at all. The visible universe is limited by the speed of light and the age of the cosmos. But beyond this horizon, there may be infinite space with infinite galaxies, or there may be an edge. Or the universe may loop back on itself. We don't know. Perhaps you live in an infinite ocean of stars, or in a finite but boundless space. Some scientists believe parallel universes exist. The multiverse theory suggests that our universe is one of many. Perhaps every quantum choice creates a new universe. Perhaps there are other universes with different laws of physics. This is still philosophy, not proven science. But the very possibility is captivating. Maybe somewhere there's a version of you looking at a different sky. We may not be the only universe, just one of many. You consist of atoms 13 billion years old. The protons and neutrons in your body formed in the first minutes after the Big Bang. Elements were created in stars, but the basic particles are ancient. You carry within you matter that survived the birth of the universe, the formation of galaxies, the life and death of stars, the birth of the solar system. Every atom in you has a history billions of years long. You're not just in space, you're part of its history. Right now is the best time for life in the universe. Stars still shine brightly, galaxies are still close, space is still not too rarefied. In trillions of years, most stars will go out. Galaxies will scatter beyond the event horizon. The universe will become cold and dark. But now is the age of stars, planets, possibly life. We live in the golden age of the cosmos. If there ever was a best place and time for life, it's here and now. We live in the age of light. Space is quiet, calm, and patient. It existed billions of years before you, and will exist billions after. Stars are born and die in a slow rhythm that's in no hurry. Galaxies dance with each other over millions of years. Space is expanding, but this isn't anxiety, just movement, slow and majestic. The universe isn't rushing, it just is, large, calm, boundless. You're an observer of all this. Out of billions of objects in space, You're one of the few who can look up and understand what you see. The atoms you consist of woke up, became aware of themselves, and now look back at the universe that created them. You're the way the cosmos knows itself. Close your eyes. Imagine all these stars, galaxies, space, time. All of this exists right now, quietly, calmly, while you fall asleep. You're part of this, and this is beautiful. We traveled far today, from the birth of stars in quiet clouds of dust to millions of luminaries, more numerous than grains of sand on all of Earth, from the sun that can hold 1 million Earths to small neutron stars heavier than our entire Sunday, from the moon slowly moving away to Uranus lying on its side, and to Neptune where wind is faster than sound. We saw exoplanets with glass, rain, and worlds wandering in complete darkness. We passed by black holes that don't suck everything randomly, by quasars brighter than entire galaxies, and by nebulae, calm clouds where new stars are born. We remembered that every atom in your body is older than the Sunday, that you're created from the same matter that once shone in the hearts of the first stars. That time and space flows differently, and space can bend, pulsate, and carry waves that reach us across billions of years. And now, when your eyes become heavier, when breathing softens, allow yourself to sink into calm. Imagine the night sky above you, quiet, deep, scattered with the light of stars that were born, lived, and faded long before humanity appeared. Imagine that somewhere at this very moment in the universe, a new star is being born, and its light will someday come to you too. You're a tiny particle of the enormous cosmos, but at the same time, an entire universe of thoughts, feelings, dreams. That you exist is already a miracle. As quiet and deep as the light of distant galaxies, breathe slowly, release the tension. Allow yourself to fall asleep under the gentle breath of the universe. Sleep peacefully, sleep easily, sleep knowing you're made of starlight.